Welcome to the math class methods. In this lecture, we'll be understanding what the math class is, some of its methods and its constants, and then we'll be looking at how we refer to these different math class methods, and we'll be doing that in a live programming environment and Dr. Java. So first of all, let's understand what is a math class. So a math class, as you can probably tell, is a class that's used for mathematical operations. And these operations include things like getting square root, getting absolute value, and you may be wondering about how you would do these things in Java. And the math class is the solution. And one of the important parts of the math class is that everything is static. And by static, as you remember, means that every method, if a method is static, it's only executed within the class itself. It's not executed by different objects. So this means that there are no math class objects. Now let's take a look at some math class methods. The first method we'll be taking a look at is the square root method. And the square root method is a static method, as are all math class methods. It returns a double value and it takes in a double value. So basically the method name is sqrt and it takes in a double value and it simply returns a double, and it can be any value and it returns a double. And that's all it does. It's really simple, really basic. Next we have the static another method, which is the absolute value method. It's also static. It returns an integer and it also takes an integer and basically gives the absolute value back of an integer. Then similarly, you can replace the int with a double if you would like to use a double. So it returns a double value and it takes a double value. And then the last method that we need to understand for the math class is the power method, and it's basically like exponents. So what it does is it returns a double. It's a static method like all math class methods, and it takes two parameters, two doubles as parameters. And the first parameter is the base and the second parameter is the exponent. So if you were to put the first parameter as 3 and the second parameter as 2, that would be 3 to the power of 2. So basically that would be 9, and that's what the program would return. And so let's take a look at the constants that we'll need to know. And there's actually only one constant that we need to understand for this specific class, and one very, very important constant, and that is pi. And math.pi is used to represent pi. So there's no pi symbol in programming. This is the constant that is used to represent pi. So whenever you're doing something maybe related to circles or you need to use pi on any occasion, this is the constant that you should use. So now let's look at how are we going to refer to these math methods and constants by moving over to Dr. Java. So here we are at Dr. Java, and we have the math test class set up with its declaration and the main method declaration. And now what we're going to be doing is we're going to be testing out the different methods, and we're going to see how they work. So let's say double x equals, and let's say that we want to set it to a value of the math.sqrt square root of, let's say, 4.0. Okay, so what this is doing here is we're using the math method. So as you notice, we say math with a capital M, dot, and then whatever the method name is and any parameters if necessary. And what this should do is this should give this x a value of 2, and let's print out just to make sure that's working. So here we're gonna print out x after it's been calculated to have a value of math dot square root of 4. So let's compile and let's run. As you can see, the value returned is 2.0. So the math dot square root method returns a double, and that double was printed out. Next, let's take a look at the absolute value method. So for this one, I'm going to say math dot abs. And absolute value, as you know, it basically removes the negative sign if there is one, so negative 2.3. So this should turn the value of x into 2.3 by basically implementing an absolute value. So we should get 2.3 printed out. Let's compile and run this program to see what happens. So compile and then we run. And as you can see, 2.3 is printed out. Now similarly, let's say if I were to make this an integer, and if I were to compile this, we would get an error. And the reason we would get an error is because this is a double, and if the parameter is a double, then this method returns a double, and this is an integer, so that's not going to work out. So let's make this an integer. Let's keep it at -2. Now let's compile, and as you can see, it works now, and x should have a value of 2. So now let's run the program, and as you can see, 2 is printed out. And the last method we'll be looking at is the power method, so POW, and it takes 2 parameters. So let's give it a parameter of 4, 2. And what this will do is this will raise 4 to the power of 2 and calculate that as the value of x. And remember, it returns a double value, so we should set the value of this to double. Let's compile, and let's run. And as you can see, 16.0 is printed out, which is the value of 4 to the power of 2. And similarly, you can plug in any double integer over here and you'll get the same result. And now the last thing we'll be taking a look at is the constant, which is math.pi. So let's remove this declaration and simply print out math.pi to see what the value of this constant is. And remember, this constant is supposed to represent pi. So let's make this math.pi. There we go, pi. Notice how pi is capitalized. And now I'm going to compile, and I'm going to run. As you can see, 3.141592635, whatever exactly the digits of pi is printed out. So this is a very fair and good use for any pi values. And that's what you should use when you're trying to, let's say, calculate the area or circumference of a circle. So to recap this lecture, we looked at the math class and looked at its methods, which are the square root method, the absolute value method, and the power method, which is used for exponents. And then we took a look at the math.pi constant.